Hello, this is Miss D again. Today we'll be exploring how a pattern can be used to calculate the sum of all even fractional parts between 0 and 1. Let's get started by looking at slide B. Let's look at each row and count starting from 0 and going all the way up to 1 for each row. Let's start with the fourths. So we have 0 fourths, 1 fourth, 2 fourths, 3 fourths, 4 fourths. All right, great job. Let's go ahead to the sixths. So we have 0 sixths, 1 sixth, 2 sixths, 3 sixths, 4 sixths, 5 sixths, 7, and 6 sixths. Now let's go ahead to the eighths. 0 eighths, 1 eighth, 2 eighths, 3 eighths, 4 eighths, 5 eighths, 6 eighths, 7 eighths, 8 eighths. All right, final row, we're counting by tenths. 0 tenths, 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, and 10 tenths. Great job. All right, we're going to go ahead to slide C, and we're going to find the sum of the fractional units of 0 fourths to 4 fourths. You're going to write this sum as a mixed number. So we have to add up all the fractions to find the sum of the fractional parts of 0 fourths to 4 fourths. Pause and complete. When you're ready, press play. All right, so how did you find the sum? Did you add up all the fractions? Did you add a few fractions together, then add a few more together to get that total sum? What was your answer? Did you get 2 and 2 fourths? Great job. Let's take a look at a possible way you could have solved it. So one of the ways you could have solved it was to add the fractions that you know will give you a whole. So if we added 0 fourths and 4 fourths, that would give us a whole. And if we added 1 fourth plus 3 fourths, that would give us a whole. And then that would leave us with those 2 fourths, right? So it helped us get that answer pretty quickly. Another way you could have solved it is on slide D. So I want you to take a second and pause and think about what do you notice and what do you wonder. When you're ready, go ahead and unpause. So what did you notice? What did you wonder? Did you notice that they added up all the fractional parts to get their total? Did you notice that they decompose 10 fourths into 8 fourths and 2 fourths? Right? I wonder if they did that in order to change this fraction that's greater than 1 into a mixed number that way. They found that 8 fourths is 2, and then they had a remainder of 2 fourths. All right. Was this similar to the way that you solved it? All right. Let's go ahead and complete the rest of the slides. So I want you to go ahead and complete all the other slides up to J. When you're at J, I want you to unpause and meet back with me, okay? So go ahead and complete those slides and we'll meet back up at slide J. Okay, now that you've explored a few more problems, let's take a look at this slide here. So I want you to answer those two questions. What patterns do you notice within these sums? And how would the sums change if the addition started with a unit fraction rather than 0? So go ahead and pause and think about those two questions. And when you're ready, press play. So what did you notice? Did you notice that all sums have a fractional part of a half? So you see a half here, you see a half here, and here, and here. Did you notice that half the denominator is the whole number in the sum? So here we're dealing with fourths, and half of 4 is 2. And here we're dealing with 6, and half of 6 is 3. Here we're dealing with eighths, and half of 8 is 4. And here we're dealing with tenths, and half of 10 is 5. And did you notice that there was always an odd number of addends? So here we had 5 addends, here we had 7 addends, here we had 9 addends, and here we had 11 addends. And would the sums have changed if we eliminated the 0 and started with the unit fraction? So started with 1/4, or started with 1/6, or 1/8, or 1/10. Would that have changed the sum? No, the sum would have stayed the same. All right, guys, great job. You can go ahead to slide L, and you can continue to find patterns when finding the sums of the fractional parts. Well, we've come to the end of this video segment. Hope this video has helped you understand how patterns can be used to calculate the sum of all even fractional parts between 0 and 1. Great job. I'll see you next time.